There are a lot of things we can do with Bernoulli's principle, but one really interesting application has to do with the fluid coming out of the container at some point. Say we have a dam with some type of outlet built into it. When opened, how fast does that water come out? The water at the top is open to the atmosphere, so the pressure at the top is the same as the atmospheric pressure. Along those same lines, we can say that the water at the top is not moving downward with any real motion, so we can call the velocity at the top zero. The first part of Bernoulli's equation deals with the top of the water, so let's look at this a little closer. The velocity at the top is zero. This means that it only has gravitational potential energy, so we can get rid of that particular expression and simplify this side of the equation. At location 2, the hole is some height, h, down from the top of the water level. Since this is our bottom level, and since we are in a position to create our own frame of reference, we could very easily call this height 0. This would allow us to say that there is no gravitational potential energy at this point, only kinetic energy coming out of the water. So something to think about here. The pressure of the water as it is exiting the container is also atmospheric pressure. So we change our pressure 2 to atmospheric pressure as well. This came from Bernoulli's equation, so we set those two expressions equal to each other, and we can commence to all kinds of canceling here. Atmospheric pressure cancels out, as does the density if we factor it out. So here's something truly beautiful. We are left with a velocity squared equal to 2 times the height mg. This means that the water coming out of the hole has the same velocity as water that had simply been dropped from that height. So essentially, the water is in free fall at this point.